In this video, we'll take a look at section 6.6, which is solving radical equations. Now, our first objective, we're going to solve radical equations with one radical term. Now, our steps here for solving these types of equations is to first isolate the radical expression. Then, raise both sides to the power of the index. Now, after step 2, you won't have any more radicals in your equation. So then you're going to solve the remaining equation. And then step 4, you're going to have to check your solutions. So sometimes your solution might not work out. Let's take a look at an example. So solve, we have square root of x minus 7 is equal to 3. So my first step is to isolate my radical expression. So I want to isolate this square root of x. Well, in order to isolate that, I'm going to have to add 7 to both sides. And now I have the square root of x is equal to 10. Now step 2 is to raise both sides to the power of the index. Well, when we're dealing with square root, our index is 2. So I'm going to raise both sides of my equation to the second power. So now what happens is square root and second power, these cancel out with each other, leaving me with x is equal to 100. And now my equation's already solved, since I have my x completely by itself. But remember, we have to check our solutions. Whenever you raise both sides to an even power, you're going to have to check your solutions for that equation. So let's go ahead and check. So we're checking if x is equal to 100. So let's go ahead and plug it into our original equation. So we have square root of 100, and then we have minus 7. We want to check to see if this is equal to 3. Well, simplify. Square root of 100 gives me 10. 10 minus 7, that does give me 3. So we're okay. So x equals 100 is our solution. Let's take a look at another problem. Solve. Square root of x is equal to negative 2. Well, now in this particular problem, my radical expression is already isolated. My square root is already by itself. So I can begin by raising both sides to the second power. So now my square root and second power cancel out with each other. I get x is equal to positive 4. But let's go ahead and check that. So plug in 4 into our original problem. So we have square root of 4. And we want to check to see if this is equal to negative 2. Well, square root of 4, this is equal to positive 2. So I have positive 2 is equal to negative 2, which is not a true statement. So this x equals 4, we have to get rid of that solution. So our final answer will put no solution. Okay, so make sure you always check your answers and make sure it gives you a true statement when you plug it into your original equation. Let's try this next problem out. This one a little bit more difficult. So we have x plus 2 is equal to, now I have the square root of 2x plus 7. Now my radical expression is already isolated. It's just on the right-hand side this time. So now let's go ahead and raise both sides to the power of the index, which in this case is 2. So square root, second power, cancel out with each other. But now on this left-hand side, x plus 2 raised to the second power, be careful there because this is x plus 2 times x plus 2. And I have equal to. On the right-hand side, square root and second power canceled out. I'm left with equal to 2x plus 7. Now let's continue to solve. Let's actually multiply out the x plus 2 times x plus 2. You're going to have to distribute. Okay, so first, x times x gives me x squared. X times 2, I get 2x. Now let's go ahead and distribute out this 2 to both of these terms. 2 times x, I get 2x. 2 times 2, I get 4. Now let's continue to simplify it. I can combine like terms. I get x squared plus 4x plus 4 is equal to 2x plus 7. Now, since my equation, I have an x squared. I want to get one side equal to 0. I want to get it into standard form. So now I have x squared plus 2x minus 3 is equal to 0. And now I can factor. So two numbers that multiply give me negative 3 and add up to positive 2. We'll have x plus 3 and x minus 1. Now you could go ahead, set each factor equal to 0, and then solve. So for the first equation, go ahead, subtract 3 from both sides. Second equation, add 1 to both sides. I get x is equal to negative 3, and I get x is equal to positive 1. But remember, check your solutions. So let's plug in these values that we got for x into our original equation and make sure it gives us a true statement. So let me just write out the equation. We had x plus 2 was equal to square root of 2x plus 7. So now let's check. So let me go ahead and check x equals negative 3. So if I plug in negative 3, I get negative 3 plus 2 is equal to square root of 2 times negative 3 plus 7. So negative 3 plus 2, I get negative 1 is equal to the square root of, so 2 times negative 3, I get negative 6, and then plus 7. So I get negative 1 is equal to the square root of 1. But square root of 1, try to squeeze this in, I get negative 1 is equal to positive 1, which does not work out. That's not a true statement. So that x equals negative 3, we have to get rid of that solution. Now let's go ahead and check x equals positive 1. So let's plug it in. We have 1 plus 2 is equal to square root of 2 times 1, and then plus 7. Start simplifying. 1 plus 2 gives me 3, and I have equal to square root of 2 times 1 gives me 2, and I have plus 7. So I get 3 is equal to square root of 9. So I get 3 is equal to 3, which is a true statement. So my only solution here is x equals 1. So just remember, always check your solutions. Let's take a look at another problem. Now we have x plus 1 is equal to 3 times the square root of x minus 1. Remember, our first step is to isolate our radical expression. So since this is 3 times the square root of x minus 1, I'm going to go ahead and divide both sides by 3. So now this leaves me with x plus 1 over 3 is equal to the square root of x minus 1. Now that our radical expression is isolated, we're going to raise both sides of the equation to the power of the index, which is 2. So square root, second power cancel out. Now on the left-hand side of the equation, x plus 1 over 3 raised to the second power. I have to raise the numerator to the second power and the denominator to the second power as well. And on the right-hand side, I just have x minus 1 because the square root and second power canceled out. Now, x plus 1 raised to the second power, remember, this is x plus 1 times x plus 1. So if I actually multiplied it out, if I expanded it, I get x squared plus 2x plus 1. And I have all over, 3 raised to the second power gives me 9. So now we don't have any more radicals, but I do have this fraction I want to get rid of as well. So I'm going to go ahead and multiply both sides of the equation by 9. That way I have an equation without any fractions. So now I have x squared plus 2x plus 1 is equal to 9x minus 9. So this 9, you have to distribute out to each one of these terms. So now I'm left with the quadratic equation, which means I have to get one side to be 0, get in standard form. So I'm subtracting 9x from both sides and I'm adding 9 to both sides. So I have x squared minus 7x plus 10 is equal to 0. Now we could go ahead and factor. So two numbers that multiply give me positive 10 and add up to negative 7. I can use negative 5 and negative 2. So I have x minus 5, x minus 2 equals 0. go ahead, set each factor equal to 0 and solve. Well, I get x equals 5, and I get x equals 2. Okay. Now let's check it. Check our solutions. Okay. So let's go back to our original problem. Let me go ahead and check it from here. So one of the solutions we got was x equals 5. So if I plug in 5 into my original equation, I'd have 5 plus 1 is equal to 3 times the square root of 5 minus 1. Well, 5 plus 1 gives me 6, and I have equal to 3 times 5 minus 1 gives me 4. So I have the square root of 4. So I have 6 times square root of 4. I'm sorry, I have 6 is equal to 3 times the square root of 4, which is 2. So I get 6 is equal to 6. Okay. So that solution checks out. X equals 5 is okay, it works. Now let's go ahead and check the other solution, which was 2. Let's plug in 2 and see if it gives us a true statement. So I'd have 2 plus 1 is equal to 3 times the square root of 2 minus 1. 2 plus 1 gives me 3. I have equal to 3 times, okay, 2 minus 1 gives me 1. So I have 3 times the square root of 1. So I have 3 is equal to 3 times 1, which is a true statement as well. So both of my solutions are okay. They both work out. So in this particular problem, we have two solutions. So we have x equals 5, which worked, and x equals 2 also works. Next problem. This time we have the fourth root of x minus 1 minus 2 equals 0. Well, our first step is to isolate the radical expression. So let's go ahead, add 2 to both sides. So I have the square root, sorry, not the square root, we have the fourth root of x minus 1 is equal to 2. And now we have to raise both sides of the equation by the power of the index. But now be careful here because our index is 4. So we're raising both sides to the fourth power. So now fourth root and the fourth power cancel out with each other. So I have x minus 1 is equal to 2 raised to the fourth power gives me 16. Now my next step to solve for x, just go ahead, add 1 to both sides. I get x is equal to 17. Now let's check it. So if I plugged in 17 to my original equation, I get the fourth root of 17 minus 1, and I have minus 2 is equal to 0. Let's see if this is a true statement. Well, 17 minus 1 gives me 16, so I have the fourth root of 16, and then minus 2. I want to see if this is equal to 0. Fourth root of 16 is actually 2. So 2 minus 2, that gives me 0. So x equals 17 checks out. Let's take a look at another problem. So I have the cubed root of 3y plus 6, then plus 2 is equal to 3. So isolate the radical expression. Let's go ahead and subtract 2 from both sides. So I get the cubed root of 3y plus 6, and I have is equal to, now 3 minus 2 gives me 1. So my radical expression is isolated. So we're going to raise both sides of the equation to the power of the index. So our index here is 3, so I'm raising both sides of the equation to the third power. So cubed root and third power cancel out. So I have 3y plus 6 is equal to 1 raised to the third power, which gives me 1. Now we go ahead and solve for y. So I'm going to subtract 6 from both sides. I get 3y is equal to negative 5. And now we can go ahead and divide both sides by 3. We get y is equal to negative 5/3. Now, for this particular problem, I don't have to check my answer. The reason why is since I didn't raise both sides to an even power, since I raised it to an odd power, my solution is going to be okay. And if we did check it, let's go ahead and do a quick check. So 3 times negative 5/3, that gives me negative 5. So I have negative 5 plus 6, which is, so I'm plugging it here. So I have negative 5 plus 6, which is 1. Cubed root of 1 is 1. 1 plus 2 gives me 3. So it checks out. take a look at one last problem. So solve cubed root of x minus 2 is equal to 3. All right, well, in this particular problem, our radical expression is already isolated. So I'm going to raise both sides to the power of the index, which is 3. So cubed root and third power cancel out. So I have x minus 2 is equal to 3 raised to the third power gives me 27. Now next step to solve for x, I could go ahead and add 2 to both sides. I get x is equal to 29. Now since I raised both sides to an odd power, there's no need to check your answer. Well, if I did check it, okay, I have 29 minus 2, which is 27. Cubed root of 27 gives me 3. So that was it for section 6.6. Remember, if you have any questions at all, email me and I'll help you out.